All right, we're mostly going to talk about algorithms today, but any questions on the ODP or on PA1 or on anything? That's either really good or really not good. All right, so let me give you a simplifying assumption you can make on PA1. You can assume that when the user is supposed to type in a number, they do type in a number. Okay? It might be negative, it might be bigger than 3 or bigger than 10 or less than 10, right? Or it might be 0, but you can assume they're going to type in a number, okay, a valid integer. So you don't have to error check for, they type in a string of weird characters, or they type in a number with a decimal point in it or something like that. If they're putting in the number of sticks, or if they're putting in how many sticks they want to take, you can assume they're typing a valid integer. It could be positive, negative, or 0. So you need to check the range of it, right? If it's supposed to be bigger than 9, you got to make sure it's bigger than 9, and so on. But you don't have to do any other error checking. Programming assignment 2, when we do the same thing in C, that one we're going to get really picky on the error checking, because we've got C, we've got scanf and things like that, so we can take that apart and make sure they put in exactly what we want. But for PA1, don't get bogged down in all the weird possible ways that the user might type in something strange. Does that make sense? All right. So I posted a couple of announcements on Canvas. So the first one is about 215. I want to make absolutely sure of the following. If you are planning to graduate at the end of June, okay, and transfer to a university this coming fall, please make sure that you have met with either myself or Izad and set up a plan of study. Okay, very, very important. Make sure that your plan of study is up to date. If you met with us a year and a half ago, you probably want to stop in and sort of make sure that everything's up to date. And run a degree audit on yourself periodically. People are probably doing this already, but that's something you can do through your student portal, and it'll tell you if you've got missing requirements. So it'll say, you never took humanities here and you need to take humanities or whatever. And make sure your plan of study includes discrete structures, CSE 215, okay? That's required to transfer as a junior to WSUV. It should be on everybody's plan of study, but make sure that you're scheduled to take CSE 215 either right now, which means you're taking it, or in winter quarter. Okay, those are the only 2 quarters it's offered. If that's not the case, definitely come and talk to one of us as soon as possible. Make sense? All right. So one other announcement, and this goes under the category of extremely important. The 215 thing's really important too, but this is timely, okay? So I have posted, in hopes of heading off unfortunate circumstances, things to please be careful about with PA1, okay? Things to make absolutely certain of. Make sure that you have a repository on GitLab, not GitHub, okay?
Typo in GitHub.
Say what?
Typo in GitHub.
Or GitHub. Definitely don't put it on GitHub. So a repo on GitLab named PA1, okay? Uppercase P, uppercase A, digit 1. Okay, not lowercase, not program 1, etc. Make sure your script is in the top level directory under PA1. Don't put a subdirectory under there called source or scripts or PA1 or something like that. PA1 should have a file called stick. Okay, it can have other files. It can have a README, it can have test files and things like that. But make sure it has your script named stick, and make sure it's called stick, S-T-I-C-K, all lowercase, not stick.sh or program1 or something like that. Okay, make sure it's executable. If you're developing this on the server and you've been testing your code, it's executable. Okay, but if you're developing this under an IDE on Windows or something like that, and then you just take the file and you copy it over to GitLab, it may not have the execution bit set, right? So make sure, even if you're developing this outside of the Linux server, which I really hope you're not, Okay, but if you are, make sure before you declare this project done that you've tried running it on the Linux server by just typing its name. Okay, so make sure it's executable. Make sure you've added Nick Macias, that's me, as a member. Okay. And there's two Nick Maciases if you just start typing Nick Macias. There's also a Nick Macias 3, that's a different account that I have, okay? That won't work. You gotta add Nick Macias with that exact spelling. And make sure I'm a reporter, not a guest. If I'm a guest, I'm not allowed to really do anything, including look at your code. If I'm a reporter, then I can download your code. And make sure you've got all this done by 8 a.m. Friday morning. Okay? If you've got all of those things done, I should be able to grade your project. Okay, that's the goal. So sometime Friday, I'll hit the big red go button on my machine, and it will talk to GitLab, and it will try to download each of your repositories using the GitLab ID that you submitted on homework 1. Okay, and it will just look for a repository called PA1. If it doesn't find it, if I don't have access to it, if anything goes wrong, I'm just not going to have your code to grade. Okay? I will try to send you a note sometime Friday, it might be late Friday night, saying, hey, there's a problem with your submission. Okay? And you want to go through these lists again, you want to make sure that all these things are done. Okay? If it's not received by the deadline, you get a 25-point deduction. Okay? But I will still grade it, assuming that you get it turned in by Saturday morning at 8 o'clock. If it's not in by Saturday at 8 o'clock, it's a 50-point deduction. But if you get it in by Sunday at 8, I'll grade it. Okay? If it's not in by Sunday at 8, it's going to be a 0. And I'm okay doing this because almost everybody did homework 1, right? And this is the same process that you did for homework 1. So whatever you did there, right, in the end that worked, that's what you want to do here. Okay, so everybody can do this, but you got to make sure you got all those details. Now, if it's called stick.sh or something, I'll take off some points, but I'll still go ahead and grade it, right? But if I can't download it because I don't have access, or it's not called PA1, or you didn't put it on the repo, right, then there's nothing that I can grade. So that's where we get into the 25-point, 50-point deductions. Does that make sense? All right, so the last note on here, hopefully try to do this early, right? So tomorrow, unfortunate timing for this, I'm not going to be available after class. Okay, I'm leaving here at 11 o'clock, right after this section, and I'm not going to be available until very late that night. I'll be done about 11 p.m. If I have like one email from one person saying, hey, can you help me with this? Yeah, I can probably do that, but I'm probably going to have like 20 or 30 or 40 emails, and they're just going to have to wait till Friday. So you're not going to be able to reach me Thursday afternoon or night for help by email. So where do you get help? Right now, right, when I say any questions, which I'm about to say, you can ask questions. You can catch me in office hours. I got 2.5 hours Thursday morning. Okay, very few people are coming by to take advantage of that. Come by, you can bring your laptop, we can look at your code, we can look at your Git setup, right, all that kind of stuff. And we got class tomorrow. Okay, so try to get this done or done enough that you've encountered all your questions before class tomorrow. Make sense? All right, so any questions? Yeah?
Are you going to be giving any feedback to our actual code, or are you mostly just checking if it works or not?
You mean once I start grading it?
Yeah.
So I'll run your program, I'll play several games, I'll let the computer win, I'll beat the computer, I'll make sure all of those things work. If everything works great, and the code looks like it's well written, and it's nicely indented, and it's well commented, right, I'll probably just say, you know, looks really good, and you'll get 100. Okay, if you get 100, it probably means things are really good. If it's absolutely knocks my socks off, right, this is like amazing code, this makes me cry, I'm so happy, right, I'll talk to you about it, okay, and you know, I'll probably ask you, you've been writing bash for a while, right, and that kind of thing. If you get 100%, but there's no comments in your code other than that comment block at the top right, I might say things like, it would be good to add some more commenting, right? Stop by and we can talk about where you might comment this. So I'll generally give you feedback if there's anything I feel like I want to discuss about it. And if it just says excellent work, it doesn't mean I just ran it and it worked and I'm done, okay? I still looked at the code and I still tried a bunch of different test cases and things like that, so. And ballpark, I'm usually taking like 5 to 10 minutes per program to grade it. Now, if it doesn't work or if there's a syntax error, right, I might try to fix that syntax error to see if the rest of your code works. You're going to lose a bunch of points because it didn't run, it gave a syntax error. But you know, I might spend time trying to debug your code so that I can test the other parts of it and give you credit for that. That's not something that'll always happen. That's not something most teachers will do. Okay, but particularly at a first assignment, you know, I want to know what you did get to work. I don't want to just say, oh, it didn't work, we're done, you know. But then that's where it ends up being like, you know, 20 minutes per grade, so do the math, 60 projects. So I'll be playing lots of stick picking games this weekend. Yeah, it's really fun when we get to like tic-tac-toe games and stuff. Then it's just like, get back and play tic-tac-toe. All right, other questions? So make sure you have that comment block in the beginning, okay? It's described in the assignment itself. Put in your name. Name's the most important thing, okay? If your name's not on the code, it's a 0. Okay, because I really, really, really want to make sure people put their name on their stuff. All right. I'm done with that. So, yesterday we were talking about pseudocode, and we were looking at algorithms for PA1 in particular, but in general. What I want to do this afternoon is work as a class on how we can describe algorithms. And we used pseudocode yesterday where we just kind of wrote things out in sentences, right? Read a number from the user, compare it to this, and, you know, if this is true, do that, and then an arrow saying go back up here, those kinds of things. So pseudocode is fine if you're comfortable thinking that way, but in ECS 120 and usually in 270 we talk about flowcharts. Right, so flowcharts are these things where you have a start and you do some input, and you can do statements, and then you can have these decision blocks, which have a yes and a no, and you can go down here, and here's another decision block. And flowcharts work great for some languages because they allow you to make spaghetti code, right? Which was typically what happened over time with code in languages like Fortran, where you had to use gotos. Right? Fortran 4 didn't have looping built in; it had gotos and ifs. And so your code kind of goes all over the place, and it gets confusing to figure out what the flow of the code is, and so a visual picture may help, or may just let you know, I should be using C or something, because this is a mess. Flowcharts don't really work well for things like while loops. Now we can code a while loop, while condition 1 do A, done, and maybe we do something before and we do something after, right? And we can write a flowchart that says let's do B, and then let's check condition 1, and if condition 1 is true, then we're going to do A, and we're going to go back up here, and if condition 1 is false, then we're going to leave our while loop, and in this case we're going to do D. Thanks. So the mapping from here to here is a little wonky, right? So I want to show you a different kind of visual tool we can use to create pseudocode that will still give us a visual view of what our flow looks like, but that works really well with things like whiles and also with if-then else's. And I've never seen these done anywhere other than when I was taught them originally, which was probably close to 40 years ago. These are called structure charts. So we don't need arrows in here. We don't have to code things as go-tos. So here's a sample structure chart. Suppose we want to do statements S1, S2, and S3. So we just make a block and we say let's do S1 and let's do S2 and let's do S3. Alright, so you just list them one below the other. No space in between. Alright, now suppose we want to say if condition 1, then let's do statement 4. Okay, so an if codes like this. So condition 1, and it could be true or it could be false. And if it's true, we want to do statement 4. And if it's false, we're not going to do anything. So we can draw an empty block. And then let's say we go on and we do statement 5. So looking at this picture, it's really clear that S1, S2, S3, and S5 always happen, right? But S4 only happens on this sort of side branch which we're following when condition 1 was true. And if we really meant that if condition 1 is true, we should do S4 and S5, but not do those if condition 1 is false, right? It's pretty clear that S5 should be, in this little half structure over here, right? And it shouldn't be true under the false side of the condition. So that can help you with the nesting of things. If you're indenting your code in a very consistent way, particularly in C with curly brackets, right? It's pretty easy to look at your code listing and know what's being done inside what. But we don't always stick to a consistent style of indenting, especially when we're editing code, when we're making changes to it. Sometimes we just start putting everything in line, and that's when you can accidentally have something on the wrong side of an else statement, for example. So let's do if C2, then S6, else S7, and then go on to S8. So here's condition 2. If it's true, we want to do S6. If it's not true, then we want to do S7. And then either way, we want to do S8. So let me throw some brackets in here. Alright, is this making sense? Alright, so we can code loops also. So while condition 4 is true, let's do S10 and S11, and then let's do S12. So while loops get written like this. You say while the condition, and then draw your box to include a vertical piece, and we can put the body of the loop in that area. So while C4 is true, we want to do S10 and S11, and then when we're done, we want to do S12. And you can nest these things, right? We could put an if statement in here, and S10 could itself be an if statement that has 2 columns underneath it. Or we could have nested while loops. So we could put another while loop inside here, or combinations. All right, and that's the whole litany of structure charts. Okay, so you've got 3 things. You've got sequential statements, you've got conditional blocks, and you've got loops. And those are the only things you need to have a fully universal programming language. Now, a couple of things. We don't have a direct way to represent for loops in here, but I'm still suggesting you don't do for loops. Because if you can do a while loop, you can do everything, and so writing a for loop as a while statement is good practice with using whiles. And once you can use whiles, if you decide to use a for loop, other than the weird syntax, it's totally straightforward, right? For initial condition.
I've completely forgotten what a for loop is.
Well, you're going to make me write it. And
No, I'm not going to make you write it. So I feel like if we're just going to ignore it, then don't worry about it.
So they're good to know, and certainly at a job interview, if someone asks you to write a for loop, you don't want to say, I don't know how to do that. So for I equals 0, I less than 10, this is your quintessential for loop. So it's some set of initial conditions. You don't have to have an initial condition. If there's nothing you need to do here, you can just have that blank and have a semicolon. Don't say for parentheses I semicolon. I is not really a statement. It'll compile, but it's kind of weird looking. If you don't want to initialize, just say semicolon. But if you want to initialize something, typically a loop variable, you put it right here. Here's the condition under which the loop should continue. So it's basically while I is less than 10. And here's something to do at the bottom of the loop. Okay, so this is done outside the loop. And then it checks if this condition is true, and if it is, it executes everything in the body of the loop, and then it does this at the bottom.
Is a for loop not more efficient than a while loop?
It's really hard to say if it comes down to it, but the difference would be pretty minute anyway.
Okay.
A good compiler can probably take advantage of the fact that you coded it as a for loop and do something fancy.
Okay.
But obviously this could be a while loop, right? You
Yeah.
just initialize that. You say while this is true, and at the bottom of your while loop you say I++. That's really all a for loop's doing for you.
So
But this happens so often that we have a special statement for it.
in C, would it do the increment before it does the check for the condition?
It will check the condition at the top of the loop, and it'll do the increment at the bottom. So the first time through, if I said for I equals 20, I less than 10, right, it will not run. If I said for I equals 9, I less than 10, it'll run once. And at the bottom, I will become 10, and then it'll kick out. It's a really good test question. Here we go. That might be a good test question, I said.
Oh, sorry, I thought that something was coming.
No.
Okay.
No, I just envisioned a set of questions like for I equals 9, I less than 10, I++, how many times does the body of the loop execute? That kind of thing.
That's a test question.
Could be. So structure charts. Okay, so the other thing with structure charts, we don't have a break statement. All right. In real life, we have a break statement we can kick out of a loop. There's really nothing wrong with break statements. I don't like them personally. That doesn't mean that I would take off points for them, but when I'm writing code, I usually don't use break statements. I prefer to code my condition in the while loop in such a way that that's when we're going to exit the loop. But sometimes a break statement just makes perfect sense, right? But there's no way to put these inside this kind of structure chart. So when we're writing these, we don't want to have a statement like break, okay? Part of the challenge for this would be how can I construct my while statement so that it does the right thing, okay? Because we're going to play around with these in a minute. So that's just an extra part of the challenge. So you can nest these things, right? You can put loops and loops and so on and so forth. Questions about this? So let's start playing with this. by writing some code. So so the first piece of code is find the average of 5 numbers entered by the user. So we want to come up with an algorithm that lets the user type in 5 numbers and then prints the average of those numbers. And a real simple algorithm would be just read A, comma B, comma C, comma D, comma E, and then print A plus B plus C plus D plus E over 5. But that's not the solution I'm looking for, because I want this to be generalizable to input 500 numbers and print the average. Okay, so we want to come up with a way to do this using a loop. And I don't want to use an array because, again, I don't want to restrict them to just entering 5 numbers. Okay, so we want to figure out the average of the numbers kind of as they're putting the numbers in. And so one question I usually ask myself when I'm trying to do a program is, how would I do it? Right? If I was stranded on a desert island with nothing to do all day except take the average of 5 numbers that my friend gives me, how would I do that? Right? What would be the steps? And it would probably be something like, well, I'll just take each number and add it to a running sum. Right? So a running sum is something that just starts off at 0, and each time you get a number, you add it to that sum. And after you've gotten 5 numbers, if you've done that for each number, that sum is the sum of the 5 numbers. And that's all you need to compute the average. Then you just divide by 5.
And then divide by the index if you use a loop.
And divide by whatever the number, yeah, the index if you use a loop. If it's not necessarily 5. So, so what would this look like in like pseudocode if we just wrote out sentences to describe this? It might be something like read a number from the user, and then we want to add that to a running sum, so sum equals sum plus the number. So we have to make sure we initialize that sum to 0. And to make sure that we actually do this 5 times, we need some kind of loop counter. Right, so this is one of the things we do with loops, is we make something happen a certain number of times. So we could do something like count equals 0, and then we could say while count is less than 5. Read a number from the user, add it to the running sum, and then don't forget to increment your count. And you got to think about edge cases, right? Do I want to start from 0 or 1? Do I want to say less than 5 or less than or equal to 5? And just try it with a small, try to go through 2 times, right? If I start with 0, first time through it's 0, it becomes a 1. Second time it's 1, becomes a 2. It should exit when count's equal to 2, so I'm going to say, well, count is less than 2. Right, so 5 should work, and then print sum over count. So does that look reasonable for like old style pseudocode? So let's make a structure chart for this. And you can put multiple statements in a block. It doesn't have to be a separate block for each thing, but if you've got different sections that are doing different things logically, you might put them in different blocks. It's really a tool for your own use to help you organize your thoughts. So while count is less than 5, so this is going to be a while. And what do we want to do in here? We want to read a number. add that to a sum. And we want to increment our count. That's the body of the while loop. And then when we exit that loop, we can calculate the average. Does that look reasonable? So the idea of using these charts is to, before you start writing code and you try to remember the double brackets and the weird spacing and all of that stuff, or you're writing C code and you got to declare variables and compile and all of that. Before you get to that level, right, you're organizing your thoughts about the algorithm itself. But this, if I wanted to turn this into a bash script, it's pretty mechanical if you understand bash. This is literally sum equals 0. This is literally count equals 0. This is while bracket bracket count dash LT5 bracket bracket, right? This is read num, or maybe, you know, echo enter a number and then read num. This is sum equals $paren, same here. The keyword done, and then this is an echo $paren. If I wanted to convert this into a C program, it's a different conversion, right? These are the same, but I need some integer statements to say they're integers. This is a while statement. I need a curly bracket. This is something like a scanf, or an fget and an scanf, and so on. Right? If I want to write this in Java, same thing. It's a different set of code that I would map to, but I don't have to figure out the algorithm again just because I'm using Java, or I'm using Python, or I'm using Snowball or something weird, right? So this is supposed to capture your algorithm, okay, and then let you convert that into whatever. And if there's a problem with your code, right, if it's not doing the same thing, if your average is always off by 20%, right, you come back to your algorithm and you say, is this algorithm correct? So you pretend you're a computer and you set sum to 0 and count to 0, and you pretend that you're reading a number and you write down the value of that, and you do each of these steps, right? And when you're done, you print out the average. Now if the average is correct, then maybe something went wrong converting this into code. But if you go through this algorithm and your average is coming off by 20%, you probably coded this perfectly, but there's a bug in the algorithm itself. All right, but it partitions your debug space. All right, you ready to try this?
Yes.
So here's you're getting it whether you're ready or not, but thank you. So read numbers from the user until they enter 0. And then print the average, not including the 0. So they just keep entering numbers. They put in a 5, they put in a 6, they put in a 7, they put in a 0, right? Your program should print the average of 5, 6, and 7. If they put in a million numbers and then they put in a 0, your program should print the average of those million numbers. So what I'd like you to do is, working individually, take about 5 or 6 minutes and try to write an algorithm as a structure chart to perform this task. And I'm going to pass out some paper. If you don't have paper, you can pass these down and take a sheet if you want. You only have paper? Okay. And let me give you one more caveat. When I collect these in about 5 or 6 minutes, I'm going to go through them. I want to put some of them up and look at them and talk about it as a class. Okay? So number 1, don't put your name on it. unless you really want your name broadcast, okay? But if you're not comfortable with that, if you don't want your code shown even without your name, then on the top just write very clearly, do not show. Okay, and I won't show it to the class. But if you do that, put your name on it so that I know who did this, and then I might send you an email and say, hey, let's talk about structure charts or something. But if you don't want it shown, just say do not show. Otherwise, I'm going to pick some and we're going to talk about them. Make sense?
Can we put comments in this?
You can.
Just on the side.
Yeah, just throw on the side. All right, so take another minute, and then I'm going to go ahead and have you pass those forward, and we'll start talking about them. Yeah.
Pressing in just the second thing.
Yeah. All right, go ahead and pass those forward. Let's see what we came up with. And it's not graded, and I know this is a new thing, and so don't worry if it's taking longer than you thought.
Can you just put in more work?
It's the benefit of sitting in front.
Any more work?
Cool.
Yeah, you kind of stress me out with your dope.
All right, we got everybody?
I saw that part jump, you really like that. Okay, I like that.
Look at that too? Oh, look at that too.
I just do like a food like that.
I thought you wanted to do the last one. I thought you wanted to do the last one. What's that?
All right, so give me a minute to eyeball these, and I'll pick out a few, and we'll talk about them. So this is cool. I'm seeing different ways to do this. All right, so let me put a few of these up. So here's one solution. Sum equals 0, count equals 0, read a number. And while the number is not 0, add it to the sum, increment the count, read the number again. Right? And then when you exit the loop, take the sum divided by the number, that's the average. So what's happening here is you're doing an initial read outside the loop. We want to loop until the number they enter is 0, but if we didn't have that, right, we don't know what's going to happen the first time through the loop. So go ahead and throw one read outside the while, read the number, add it to the sum, and then count it, and then read the number again at the bottom of the loop. right? And this is a structure you'll see again and again and again. You really want to do this stuff, but to make it work, we got to do part of this outside to begin with. So put a read up there. So that's a one perfect way to do this. And is it count or count plus 1 or count minus 1? Try to nail down in your head what the meaning of your variables are. So count is originally 0. We read a number. If it's not 0, count's going to be 1. All right. So count in this case is always going to be the number of non-zero numbers that we've read. So that's exactly what you want to divide by. Oh, we want to divide by count instead of, yeah. Yeah. So I missed that the first time. Yeah, so print sum divided by count. There's your average. Yeah.
So I did mine the same way, but the only issue that I realized is that if they enter 0 the first time through, it won't go through the loop, so then it'll do 0, divide by 0.
Yeah, so sum is 0, count is 0, while number is not 0. If you read a number and it's non-zero, then and it's 0 the first time through, your count will be 0. So that needs to be taken care of.
Just add an if statement right before that.
Yeah, sure.
If you do like count equals 1 initially, regardless, isn't it just 0 divided by?
If you do count equals 1 initially, then that's fine, but you want to make sure that, for example, if you only input one number, the count ends up being 1, not 2. So if you initialize count to 1 here, and you read one number, count would be 2, you'd read the 0 and kick out, then you'd be dividing your one number by 2. So, but that's another way of approaching the idea of setting a flag, right? And somehow using that to say don't divide by 0. But the problem didn't say what you should do if they don't put in any numbers, and there's no such thing as the average of 0 numbers. It's not necessarily 0. It's not really defined.
Whoa.
Yeah. Did you have a comment?
No, just
Okay. We are out of time here, but I'll go through these and pick out a few others to talk about. So tomorrow I want to keep doing this. We'll keep playing with some more algorithms, and we'll get some more practice with this. All right, so I'll see you next time.